All right, let's kick things off today with a puzzle. Now, on the surface, it looks pretty simple, but trust me, you're going to want to stick with this because whether you solve it or, more importantly, whether you can't solve it is going to show us something really deep about the limits of logic itself.
Okay, so here it is, the big question right up front for you. Can you produce the string MU? All you have to do is start with the letters MI and follow a couple of simple rules. Sounds easy enough, doesn't it? How hard could it be? Well, let's find out.
To even try to solve this, we have to step into this little, self-contained universe. It's called the MIU-system. Think of it like a game with its own physics. It has these super strict, totally unbreakable laws you have to follow.
So, what are the basics? First off, the alphabet is tiny. You only get 3 letters, M, I, and U. That's it. Your starting point, what we call the axiom, is the string MI. And here's the golden rule, the most important thing to remember. You can only do what the rules say you can do. No thinking outside the box, no clever workarounds. This is all about pure, formal logic.
All right, so how do we actually make new strings? Well, you've got a toolkit, but it's a pretty small one. You've only got 4 tools, and these are the only moves you're allowed to make in this entire game.
You know, there's a name for this kind of setup. It's called a formal system. And what's wild about it is that you're not supposed to think about what these letters mean. They're just symbols. You're just pushing them around according to a fixed set of rules. The chess analogy is perfect. You don't ask why a knight moves in an L shape, you just accept that it does. Same idea here.
Okay, let's break down those 4 tools. Rule 1, if your string ends with an I, you can just tack a U onto the end. Super simple. Rule 2 is a bit more fun. If you've got a string like M something, you can double everything that comes after the M. So MIU becomes MIUIU. Got it? Rule 3, anytime you see I all in a row, you can swap that whole chunk out for a single U. And last but not least, rule 4, if you see a UU pair, you can just poof, get rid of it. And that's it. Those are your only legal moves.
Okay, so we've got our 4 rules, and that's our entire toolbox. Let's see what we can actually build with this thing. If we start applying them, one after another, we should be able to create a whole bunch of new, maybe even more complex strings.
Now, here's a key piece of jargon. In a formal system like this, any string that you can successfully make is called a theorem. And this is super important. Don't think of theorem like in your high school geometry class. It doesn't mean something is true. It just means it's producible. It's reachable from the starting point. So our big question, can you produce MU, is really just a different way of asking, is MU a theorem in this system?
All right, let's see this in action. We start with our given string, MI. What can we do? Well, let's use rule 2. We double what's after the M, so we get MII. Cool. Let's do it again. Now we have MIIII. Okay, now we have a string that ends in I, so we can use rule 1 to add a U. See what's happening? We're chaining these moves together. This whole step-by-step process is called a derivation. And by doing this, we've just proven that something like MUIIU is a totally valid theorem.
So, yeah, we can make some pretty wild-looking strings. But what about mu? The whole reason we started this. It feels like it should be easy, right? It's just 2 letters. But the more you mess around with these rules, the more it feels like it's just impossible to get to. You're applying the rules, right? Your string gets longer. Then you use rule 4 and it gets shorter. Then it gets longer again. You feel like you're making progress, but that one little string, MU, it just never shows up. It's honestly pretty frustrating.
And this is where that little seed of doubt starts to grow. Are we just missing some super complicated 50-step combo of moves? Or is there something else going on here? Is it actually impossible? Is mu just not a theorem, meaning we could play this game for 1,000,000 years and never ever get it?
To get an answer, we have to do something that's totally against the rules. We have to stop just playing the game, and we have to start thinking about the game itself. We need to take a step back and jump outside the system. And this really shows us there are 2 totally different ways of thinking. There's what you might call mechanic mode. That's when you're inside the system, just cranking the handle, applying rules without really thinking. You're acting like a machine. But then there's intelligent mode. That's when you step back, you look for patterns, you start asking why. And that is where the breakthrough happens.
Now here is one of the first things you might notice when you step outside the system. Every single theorem has to begin with the letter M. Why?
because none of the rules ever let you change that first letter. It's a fundamental property.
And this gets at something really core to what it means to be intelligent. As the source material says, it's this ability to jump out of what you're doing, look at it from a distance, and find the hidden patterns. That's the real game.
So we found a pattern. But what about a shortcut to certainty? Is there some kind of ultimate litmus test we could use? A perfect test that gives us a definitive answer for any string we can think of?
Well, you could try the brute force approach. Just imagine like a super powerful computer, a genie that starts with MI and just goes nuts. It applies every rule to every new string it makes in every possible way. It would build this gigantic, ever-expanding tree of every single possible theorem.
Now, if a string is a theorem, our genie would eventually spit it out. But here's the catch. What if it's not? How would you know? You'd have to wait forever, because it could always be the very next string the genie makes. So this method can eventually tell you yes, but it can never ever give you a confident no. And let's be real, waiting forever is not a useful answer. What we're really looking for is something called a decision procedure. You can think of this as the holy grail of any formal system. It's a single, foolproof test that's guaranteed to give you a clear yes or no for any string you feed it, and to do it in a finite amount of time.
Having a decision procedure is a total game changer. It takes you from an infinite, hopeless search and gives you a solvable problem. It's the difference between guessing and knowing. It gives you the power of certainty.
And this, right here, is where our simple little puzzle just explodes into this huge, profound question. If this tiny, simple universe with just 3 letters and 4 rules can be so tricky, what does that tell us about much, much bigger systems? Like, say, all of mathematics, or all the computer programs that run our lives. It leaves you wondering, are there things out there that are true, but that we can never, ever prove?